right, thank you so much. This is a particular pleasure for me to be here in person. I became part of this, the General Semantic Society, a couple of years back over the pandemic. And doing things online is all right, but it's just, I'm super excited to be here. Also, excellent talks before this. What thrills me in particular is that I came to discover this group, a pretty eclectic mix of people from so many different disciplines. And there's so much to learn from each other, right? And that I'm able to comprehend half of what you're saying is. So I do have a title for the talk. You may have seen it. I wanted to keep you in suspense for a while. Unfortunately, technology destroyed that. But I've changed my title, by the way. So I'll give away the final goal of this presentation, which is I want to sort of demystify the nature of objectivity, right? This is sort of a strong, sort of the magic bullet that science holds over every other discipline. Korzybski himself is sort of fascinated with this. And I sort of found his love for science when I read, I'm trying to forget the name of his book now. Wrong group to forget about science. No, before Science and Sanity, the Manhood and Humanity. Manhood and Humanity. So my own sort of quest for the nature of objectivity comes from, starts at the beginning. I went into the sciences thinking that there was science had some connection to ultimate reality, that we're talking about something separate from us, that the social sciences and humanities were human affairs. And I really didn't want to bother with that. I want to look up at the skies and talk about the things out there, right? Somehow it gave me a better connection to truth. But over time, I think I've come to realize that I've been fooling myself. It's not quite the case. Science is very much a human enterprise. But so that's the final slide, right? That's my take on it, is my subjective opinion about the topic of objectivity. But let me tell you why I think that now. So I started with the myth of, this sounds a little insidious. It's not like scientists have been deliberately trying to do this. I changed it to critique of scientific objectivity. I thought it makes more sense to talk about the semantics of objectivity, right? And more than just the verbal, it's really theater. The whole scientific project is being enacted out in so many ways. And so I just want to explore with you what these different facets of the objectivity experiment looks like. So we'll start with the birth of this whole notion. In my mind, I think the Enlightenment Project is probably where most of this starts, right? And I would blame Descartes and Bacon, or attribute this way of thinking to Descartes and Bacon. More recently, I've been teaching a course on climate change. So I'm a mathematician and physicist by training, and that's what I teach. And this is at the heart of what I teach, and this is the heart of what I'm learning now, is our separation from nature. Right? The attempt to separate mankind from nature is the very first attempt to say something like, well, nature holds truth. It's out there. We're outside of it. We can look at it. We can see it. But our sense perceptions, and then the separation of mind and body. The body cannot be trusted. Our sense perceptions cannot be trusted. We must therefore attribute human ability to understand nature through something called the mind, right? Of course, the mind has never been placed or discovered yet. It's an ongoing attempt, but that's the general argument. Right? And then let's look at the definition of objectivity. And there are two. I think if you look at dictionary definitions, you'll find there's two approaches. Right? One of them having to do with the material object, to objectify, and the other as having the ones I've marked in red. I think this is what I'll focus on. Uninfluenced by emotion or personal prejudice, right? Freedom from bias. So sort of removed from the human experience in some sense. But the contradiction is you're talking about human experience all along. Well, there are shades of objectivity. You've probably seen this cartoon before, right? Many of you have seen this. This is slightly dated now. The sociologists, the people in humanities and social sciences, the qualitative areas are way behind. Everybody sort of says, I subsume you, you're part of me, you're part of me, you're part of me. And then the mathematician way out there saying everybody's part of me. Right? Interestingly enough, the cartoon is titled Fields Deranged by Purity, right? It's very telling, like purity. So purity to indicate objectivity in my mind. So the more objective, way back there, right? The least objective here. And there's some implicit hierarchy here. Objective's better. Of course, for mathematicians, one could argue, I'll get back to this point later, mathematicians could argue we're only talking about a language. Our domain of expertise, the domain of discussion in mathematics is mathematics and nothing else. Okay? Therefore, there's certainly a semblance of objectivity here. There is no intention to say anything about anything outside of mathematics, right? 1 + 1 = 2 is a rule, but if I say that's the rule I'm going to play with, that's the rule, okay? We're not talking about truth. We're just talking about rules. So mathematicians would argue that we're very objective, okay? On the other side might be the arts, where it's about human experience. So, the primary thing here is the subjective experience. There's other disciplines in between. Someone would argue would be a mix of both. There's some element of subjectivity that they want, but they also desire objectivity. And I think more and more you find in even fields like sociology, they're no longer sociology, they're social sciences, you have economic sciences, right? Everybody wants to be a science because you want this element, you want this aspect of purity within you, right? Data science, the new silver bullet, it's going to solve all our problems. But those things aside, I'm going to focus on math and physics because that's what I do, and I can say a little bit about it. I can insult them without fear, right? I'm part of that group, so it's okay for me to do that. But the question is, what exactly is happening in a field like physics? Well, because you're describing something external to yourself. I'm describing events. If I assume that I'm outside of nature, I'm describing nature, which one doesn't have to assume that necessarily, but I'm describing nature. So what are the instruments of objectivity that somebody might use in a physics or chemistry or biology or one of these quantitative sciences lab, right? The setting would be, well, these are the instruments, right? I don't see humans here. So check mark, right? We're doing well so far. What are the outcomes of objectivity? Well, it's graphs, right? I don't see people. It's all numbers, right? You can have XY plots, you can have colored graphics, you can call it aesthetic. So that's another thing that drew me to this area. For the last several years, my work has moved. I was working in problems related to mathematics and physics, but became very interested in mathematics education, in particular, the issue of creativity within mathematics. And this is what sort of gave me a glimpse. If you ask a general audience, what are the disciplines that you think are creative? We did the survey at my university. Invariably, students would say fine arts, music, theater, right? The worst was physics, and this time I was teaching physics, economics, and history were the least creative. The others were the most creative. And that, it felt like a personal insult. Like I've been doing a terrible job teaching. Yeah. Oh, what it says here doesn't matter. I have no idea what this is about. Oh, I have no idea. I can look it up for you in a minute, right? But this is not my work. I simply copied a picture of the web. Yeah, I'll show you some cool graphs that I've made. Right, very cool ones, much better than this. But that so I am obsessed with the notion that creativity lies in the domain of mathematics and sciences as well. I think scientists are very creative people, right? And this is where the element of subjectivity sort of starts to creep in. It makes you think. What is it? Why is something creative? What makes something creative? We'll get to that point in a minute. But if you look at a graph, any graph, or any scientific paper these days, they're filled with graphics. I sort of take all the blame for sort of promoting this way of thinking in my own work. But the nice thing is, I think being part of a society and a group like this, okay, speed up, talking very slowly. So let me move on. Well, communicating objectivity, right? The use of a passive voice. We teach our students to do this, right? We don't talk about us doing the work in the lab, us interpreting the results. The human is removed from the picture, right? It's chemicals were mixed, right? The light was turned on, right? Some magical person doing it. The appearance, right? The cloak of objectivity. Well, the tweed coat, for me, that's very important, right? The pipe, the bow tie, uniforms, the lab coat, right? Symbols, right? Symbols, but depersonalized symbols, okay? And there's a lot to be said about Thomas Kuhn, a philosopher of science who in the 50s and 60s did a lot of work. But one of the things he's known for, even though this was not his initial intention, is the whole idea of paradigm shifts in science, the way scientific thinking changes. There's one model that that lasts a long time. It reaches a crisis or a paradox of some sort, and then a new model is created, right? But what's interesting is the jump from model A or paradigm A to paradigm B arises because of some very creative idea, right? Well, Newton's idea of the universe was a clockwork idea because gears and machines were popular then. So he envisioned the universe as a clockwork device. Einstein came up with his theory at a time when geometry was flourishing, right? So his universe is geometric. So the way we model these things, okay, is based on popular notions of the time, right? Highly subjective. What does it have to do with reality? It's very hard to say, very hard to answer that question. That's not to put down the scientific purpose and the merits of each of these paradigms. Good stuff still gets done. And within each paradigm, you still are able to show something, right? Validate some aspect of reality. So one thing I would say is the way I will see the intervention or introduction of technologies, this sort of mathematization or quantification, is that it removes you one step further. So it's not to say objectivity is an aspiration, but we're always removed a few steps from it, right? So technology intervenes, removes the human, doesn't mean there's no human thinking at play over here. We're sort of 2 steps behind. It's sort of hiding in the back, okay? So at best, right, what technology, all this artificial intelligence idea does is displace subjectivity to some other place behind in the process. Very quickly, this is something very exciting that I've been working on recently. So I did a survey. I'm doing a study over the last couple of years in my class about mathematics, about the nature of mathematical thinking. So my students and I coded mathematical textbooks. So we call them semantic networks. We looked at key ideas. I'm doing exactly what I'm blaming science to be doing, which is quantifying things. But I'm realizing there are gaps here. So I will take credit for realizing that. So each topic is a node in this graph. And every time the book makes a connection, between two topics. I put a line between connecting them. So here's a textbook. It's a complex textbook. It takes about 2 weeks to do this per book. And this is on a topic called pre-calculus. And there's a lot of reasons why we chose this. But here's one textbook, a semantic network for one single textbook. And we did this for 10 books. Collectively, 9 of them shown here. The point being, it's the same subject being taught by, being written about by 9 different people. This is how they view it, right? What is objective about this? And the last thing I'll show you is the similar. So we picked one of the textbooks that we use and gave it to students and said, you make connections. How do you understand this? Okay. This is how the subject is offered to you. This is how we teach it. But how do you learn it? And so what I'll show you, this is a simulation, so I don't want to start it as soon because it'll get confusing. You'll see one of these textbooks, these nodes given to several, about 150 topics, each of them represented by a dot, given to students. What they will do is start building connections. So they will pull out from this initial platter, they'll pull out topics that they understand and connect them. And you'll see that evolving in time. So we surveyed periodically every week students, the same topics. So student 1, student 2. The same course. So it repeats again. Yeah. Here's another set of students. So they're making unique connections. This is mathematics. You would think that it's a mathematical topic. 1 + 1 is 2 should be understood by everyone the same way, but this is not how they understand it. Because there's other factors that play a role. A huge one, which I didn't show results here, for our emotions, right? This part of we did some neuroscience studies, and there's aspects of sort of the human brain that light up, that connect to the self and personal experiences and so on, as they make these connections. So the individual is deeply embedded in this meaning making, right? It's a very constructivist way of thinking about learning. All right, I'll stop right here. Thank you.